So this is just be a lecture to show a few more examples of doing calculations using molarity. So let's say, so you have vancomycin, which is an antibiotic that's administered by IV. So that means it would be in a solution. So it's a pretty complex molecule. It's 66 carbons, 75 hydrogens, 2 chlorines, 9 nitrogens, 24 oxygens in the molecule. So let's say we wanted to prepare an IV bag. How would you prepare? .500 mils of a 3.45 times 10 to the minus molar solution of vancomycin for placement in an IV bag. Okay, so if you want to do this calculation, so 3.45 times 10 to the minus 11. So anytime again you see capital M molarity, you should write that as moles per liter instead. So if you want to get the moles of vancomycin, then at some point, and you're given the molecular formula, so you can take the molecular formula and calculate its molar mass. And once you have molar mass, then you can convert to moles. So the first thing you would need to do is calculate the molar mass of vancomycin. So you need a periodic table, right? Look up the molar mass of carbon, multiply it by 66, the molar mass of hydrogen, multiply it by 75, and so forth. So if you did that, then you would get the molar mass of 1,449.3 grams per mole. Okay, so so you know the molarity, so 3.45 times 10 to the minus 11. Where's that minus 4? I can't read my own notes. It's minus 4, not minus 11. So let's set up a dimensional analysis, and you need to prepare 500 mils of it. So 500 liters, or 0.5 liters, 500 mils, 0.5 liters. So you need 0.0001725 moles of vancomycin, and now you can convert that to grams. So we calculated the molar mass to be 1449.3 grams per 1 mole. So you would need 0.25 grams of vancomycin. So then what you would have is set up as so you take a volumetric flask. If you need 500 mils, then you would grab a 500 mil volumetric flask. Right, you would add the 0.25 grams of vancomycin to it. And then you would add water to the 500 mil mark. And now you would have a 3.45 times 10 to the minus 4 molar solution. So if you then transferred that to an IV bag and you administered all 500 mils to the patient, you would deliver 0.25 grams of vancomycin to the patient. So a typical adult needs So adult needs about 2 times this per day. So then you would just administer 2 IV bags. Two IV bags per day to the patient. Okay, so certainly nurses would be one people that would have to worry about concentrations of solutions. Pharmacists would have to worry about them. You know, they may not prepare them themselves anymore. They may just be prepared at the company and shipped to them that way. In some cases, though, pharmacists, for example, may have to compound their own pharmaceuticals and make them themselves in their lab, and so they would have to know how to do these type of calculations. Okay, so children need smaller doses than adults, obviously. So, you know, there'd be a couple of ways you could handle this. You could either give less of the adult dosage to the child, or you could simply have a less concentrated solution of the vancomycin. So if we wanted a less concentrated solution, then we would need to do a dilution. So how would you prepare? So how would you prepare 250 mils of a 8.625 times 10 to the minus 5 molar solution? So let's prepare it from the adult dosed solution. So if you want to do a dilution, then you just need this equation, M1V1 equals M2V2. Okay, so we got 500 mils of 3.45 times 10 to the minus 4 molar, and we want to prepare 250 mils of 8.625 times 10 to the minus 5 molar solution. Okay, so again, X liters would be how much of the concentrated solution do you need to pipe that out and put into the flask to prepare the more dilute solution. Okay, so if we just solve that for X, so then X is 0.0625. 0.0625 liters or 62.5 mils. So what you would do if you were doing this in lab, you would take a pipette and pipette out 62.5 mils of the more concentrated solution into the flask for the dilute solution. And then add water. To the 250 mil mark, and you would have 8.625 times 10 to the minus 5 molar solution, which you could transfer to an IV bag and then administer that to a patient, to a child, and that would be given a much lower dosage.